related topic, and it's a water demand. I will share my slide. So can you see the slides? So we will discuss the water demand. So in order to design the water treatment plant, uh, first we need to know how much water is needed in a city where we want to establish a water treatment plant. So for that, there are various type of demand that should be taken care of. Of course, like public demand for drinking water, but there are demand for maybe industry. There might be demand for some other usage. So all that has to be taken care of. Now, in order to calculate the demand for any further treatment plant design and all, generally the maximum demand is being considered. We will discuss that in coming slides. So this whole topic will cover the water demand, how to calculate the water demand, type of water demand, and how to calculate per capita demand, and then what should be the design period, and how to forecast the population for future demand. So let's start with the need of water demand estimation. We in India, particularly in our country, the water demand majorly is from agricultural sector. This is on right hand side. You can see a figure which I have taken from a recent paper. So even in 2025, it is estimated that 80% of water will be used in agriculture, 8% for domestic purpose, and 11% in industry. So domestic water demand is very low compared to agricultural water demand. Domestic water demand on an average 135 liter per capita per day. Demand can be assumed for it's like city or town, but the very metro city or like large town with flushing system, 200 liter per capita per day demand could be considered. This is from IS code. And for industrial water demand, generally 50 liter per capita per day is enough. However, if the industrial area is very heavy, uh, means, is has very heavy industries and light and medium industry in one cluster, and all the industry uses the water for some purpose or another, then maximum 450 liter per capita per day can be taken as a industrial demand. So this is two type of water demand. Other are, so here the table listed here various type of industry that requires water, and you can see out of this the maximum demand is in paper, special quality paper, steel industry, right? So these industries are water consuming industry, and therefore sometime water auditing in these industries are necessary to find out how much water they are using. And the government also charge the water supply in these industries. So this is just for general information. It doesn't means you don't have to muck up this, but maybe this table will be used in future for calculation of water demand. Institution.
Ma'am,
Yes.
ma'am, what does per capita mean? Is it same as per person?
Yeah, per person. Per capita means per person per day. So you have to multiply by population to get total water demand per day. Okay. Institute 20 liter per capita per day. whereas it can be taken as high as 50 liter per capita per day. Demand for public usage generally 5 to 15%. 5% is on an average we take as a public usage for like fountain, public fountain, and gardening, and for to maintain the parks and all. Water demand for losses and theft generally, that losses means when there is a leakage in water supply pipeline, then that water, that like you can say lump sum amount of extra water demand should be added in order to even supply the water if there is a losses. Generally, losses are very rare. Only in some cases, when there is some pipeline is broken or some kind of problem happens, then only there is a leakage. So 15% of total demand can be added as a losses and theft demand. So please mute all your microphones. Please mute your microphones. Please mute your microphones. There is a background noise. Okay, thank you. Please mute your microphones. Okay, thank you. So now fire demand is very important demand. Fire demand means if there is any fire breakout in the city, then enough water with a 100 to 150 kilonewton per meter square, what means pressure should be available to this to like quench the fire and stop the fire is spreading in neighboring properties. So generally for fire demand, three hydrant at a time, means fire hydrant at a time will be used. One on the property which is like burning property, two on either side of adjacent property, to save those property from burning. So when they use the fire hydrant, they use three jet, okay, three jet with very high pressure, 100 to 150 kilonewton per meter square, which is 10 to 50 meter of water head, and this pressure should be maintained at least 4 to 5 hours, okay, to quench the fire. So therefore the fire demand is one of the important demand, and because it's like a huge demand in case of like big cities, uh, though the fire breaks out very, means it's not like always every day there is a fire breakout, but um, generally for big city this provision has to be there in reservoirs to have sufficient water, and to have sufficient water for any fire breakout if it happens. So so therefore, when we calculate the fire demand, we should take number of fires break out in a city. On an average, 5 to 6 fire we can assume uh, per day. But this is not. There is no like you can say it's just an assumption. It's not like this is what happens. Number of hydrants, generally three hydrants. I told you three jets simultaneously used to quench the fire. Number of hydrants, water discharge rate, at what rate water need to be discharged in order to maintain the enough pressure to reach the water to the property from like burning property from a distance away from that property. Number of hours fire stands, so how many like how many hours we need to jet the water on the property, that is what number of hours fire stand. So say for example if we say 6 fires break out in one day, and we are using three hydrants, generally three hydrants are there only, and the water flow rate is 1100 liter per minute, and number of hours needed to quench the fire to stop the fire is 3 hour. Then into 60 minutes, into I think this should be minute, right? How come it's a liter per day? Okay, so this is minute, right? 100 1100 liter per minute. So that should be changed to hour, right? So that's why 60 is here. So this is the liter per day. So this is how you can calculate the water required uh, for fire demand, and this can be converted to per capita or per person by dividing by the population of the city. So this is like usual practice to determine the fire demand. However, there are certain formula based on these are empirical formula, and these formula can also be used in order to estimate the fire demand, where P is the population in all the formula, Q is the flow rate or amount of water required liter per minute, and I think there is no other variable other than P, as we see like population is the main variable. So for large city, large water demand for fire should be there. In all the cases, P it's proportional to P, right? You can see that. So these formulas are given, and this is just one example how to use the formula, and it's very easy. The population of the city is 2 lakh, and you can calculate the water demand for fire using the different formula, and you can see that the Boston formula is actually very estimating the demand at like two times than the first formula, which is Kelching formula. So this is an like kind of estimate depending upon the population, depending upon the understanding of the city. Any one of the formula can be used. However, there is nothing you can say. Uh, it's not fixed for Indian city that these are the formula you can use and so on. So any formula can be used, and the demand can be estimated. Now, total water requirement for a city will depend upon various factors. I will just quickly go through this factor, and these are very, you can say, easily understandable things. So I will not explain it in length. Size of the city, we know that the bigger the size of the city, greater would be the demand because population will be high. In case population is low, though city is high and population is low, then water demand will be low. But it's generally it's not the case. In general, the city is big, the population is high, the water demand will be high. Climate conditions: hot climate, high water consumption, so water demand will be high. Type of uh, gentry and habits of the people. So actually type of habits means what is your the living standard. For conventional water usage, for example, the water usage in a rural area, it's all the conventional equipments are there. They use relatively very less amount of water compared to cities, where the high living standards demand high water consumption. For example, the toilets in city has flushing system, therefore there is high consumption in water, high water consumption due to this kind of flushing system which we use. Industrial and commercial activity, pressure of industrial commercial activity increases the water consumption. Okay, so with industrialization, water consumption increases. Water quality of water supply. If you will supply good quality of water, more consumption. However, it's we can also make out that though the quality yes, if the quality of water is very poor, then the consumption will be low. But good quality means there would be a saturated consumption. It all depends upon the lifestyle of the city, right? So even though if you are providing the good water quality, it doesn't mean that uh, the consumption will get increasing because of that. Okay, once the city is saturated, the population of the city is saturated and demand is become like quite constant, then it will remain constant regardless of the quality of water, if the quality of water does not degrade too much. Okay, for example, in Delhi, uh, water demand, I have not searched for the water demand in Delhi, but I don't think there is any you can say growth of the city, Delhi city, because there is no space now. Like it's almost saturated population. So even though the water quality will improve in other area, for example, there are different zones in Delhi, right? The water supply is from DJB, or and the water supply to those area are same. So further improving the quality of water may not increase that much the demand. That is what I'm trying to say. Pressure in the distribution system, high pressure supply water can reach to high storage, therefore the demand will increase. Means the consumption will increase, not the demand. Consumption will increase. uh, so you can supply the water in high rise buildings, and everybody will get water, and the consumption or will increase. Development of sewage facility, modern sewage system with the flush, high water consumption, conventional old system, low water consumption. System of supply, continuous or intermittent. Actually, in Delhi, you must have seen, I don't know, in my house, we get intermittent water supply. Means we get one water supply during like morning hours, which is between 5 to 6, 6:30, and at evening 7 to 8, 8:30. So 1 hour in the morning and 1 hour at evening. So that is intermittent water supply. Generally, in case of intermittent water supply, you have to store the water, and if the water supply is continuous, you don't have to store, but you will use the water as as it is required. So it doesn't make much difference, because it all depends upon the habit of the people who are using the water. Even though it's an intermittent supply, the water will be stored, and the required quantity will be consumed. So what cost of water? Yes, this is one of the parameter or factor that can actually control the wastage of water. If the water charges are high, then consumption will be as low as much. Means the people will not will be careful in consuming the water. But cost of watering is not that high in India. Um, uh, but this is one of the factors that can control the wastage of water, and make it very, you can say, very, uh, I don't know what should be the word. Uh, Means it will control the consumption. Policy of metering and method of charging on the basis of meter reading, less water usage; on the basis of fixed rate, high water usage. So this is again, you can understand, if you are metering if you are providing the meter, and charging the usage according to meter reading, then the people will be careful and they will use less water. But if there is a fixed rate, then they will use water as much as they can. So now we need to calculate the water demand. Generally, the per capita demand is given in IS code, right? Per capita per day. But if you take average demand per capita per day and design the reservoir and water treatment unit, it will fail when the demand goes to maximum. For example, if you will just compare two season, winter the water demand will be low, while in summer the water demand will be very high compared to winter. So, uh, designing the system on average value will not serve the demand in summer. Maybe it will be okay for winter, but it will fail during the summer. So therefore, in general, the maximum water consumption is used for designing the reservoirs and the water treatment plant. So maximum daily consumption can be taken as 180 times or 180% of average daily consumption, you can say. Maximum hourly consumption can be taken as 150% of its average, and maximum hourly consumption of maximum daily. So like 1.5 multiplied by 1.8 into 2 by 24, it's hourly, right? So you will divide 2 by 24 hours. So this is some empirical way to calculate the maximum hourly, daily and weekly demand or monthly average demand, and that can be used to compute the total demand for the city. For example, here a water supply scheme has to be designed for a city having a population of 1 lakh. Estimate the important kind of drafts which may be required to be recorded for an average water consumption 250. So this is the average water consumption is given, and we need to calculate different drafts means different requirements to get the total requirement for the city. So average daily draft 250 into 1 lakh population liter per day. So 250 into 10 is to 5 liter per day, which is 225 million liter per day. Maximum daily draft would be 1.8 of 225, which is 45 million liter per day. Maximum hourly draft, maybe maximum like water demand, hourly water demand can go up to 2.7 times of this average demand. Okay, daily average demand. We have seen the formula, right? 2.7 into q upon 24. So this, so maximum hourly draft for maximum day, right? So it is again in per day, but you can also compute it, this as hourly, maximum hourly demand in 1 hour. Okay, this is on maximum day, means when the demand is maximum, what is the maximum hourly demand. 1 hour or 1 or 2 hour there will be maximum demand. For example, I will just try to explain it in this way. Even during the summer, if there is a 24-hour continuous supply of water, maybe more water consumption you will see during afternoon than morning, compared to morning and evening, right? So that is like there would be some maximum, there would be some period where the demand would be maximum for even for maximum day. Maximum day means, for example, in even in summer, say on certain days which are like the temperature is highest in that city, or the for example, in June, say in June, like last 1 week of June in Delhi, the temperature goes as high as. This is just an example. We have to see the weather data in order to make this conclusion. But say for in Delhi, like last week of June has temperature about 40 to 45 degrees centigrade, and during afternoon the water demand is maximum. So that can be given like this. Okay, that can be calculated with this formula. So in that particular hour of those particular days when the demand is maximum, and in those days what is the hour when demand is highest, right? So then fire flow we need to calculate the fire demand. Fire demand can be calculated using any formula, as I told you. Now, this can again be calculated and converted into million liter per day. So, there are three draft we have calculated: maximum daily draft, then from if you will just do to see here, you can see 1.5 times of maximum daily consumption is maximum hourly consumption. So of maximum daily draft, from that we can calculate the maximum hourly draft, and then the fire demand also, and then we can just maximum daily draft plus fire demand will give you coincident draft, okay, which is greater than the maximum hourly draft. So we need to compare these two. If maximum hourly draft is greater then the sum of these two, then we have to design the all the facility using the maximum hourly draft. Do you understand what I am saying? Which one is greater? The maximum value should be taken into account in order to design the reservoir and water treatment plant. Everything, water demand of the city should be considered at the maximum of these two value, either maximum hourly draft of maximum day, or coincident draft, which is the sum of maximum daily draft and fire draft. Okay, so whichever is highest, that should be taken into account. So I have already explained you design period. Coincident draft I have already explained you. Design period, actually design period should be taken as 30 years. Um, and it should be counted after 2 year period of completion. Okay, after completion only the 30 years of period start. Okay, so now in order to see what is the future demand, if the city is growing, then you have to know the population. Okay, population of the city, and you can calculate the demand after say 20 years, 30 years, and so on, because you are designing the whole treatment plant for 30 years, say. After that you have to renew the plant according to the current population. So the population should be projected for the future years, and that can be done using various methods. One of the very simple method is to assume that population growth is linear, and the same formula y is equal to mx plus c can be used. So here Pn, which is the population in coming year, is equal to population in present year plus n number of years into x bar, which is growth rate, average growth rate. So arithmetic growth rate. Generally, population growth follows this curve. This is what and it's not assumption. This is kind of empirical understanding. And initially, when the city is growing and when the city is actually established, the growth rate is exponential, and after certain period, it's like huge growth rate, but it's a linear in like point B and D. You can see, and then once the saturation point uh, um, occurs, then the growth will be very slow or maybe even negative. Okay, so after the saturation point means if the city is fully grown and the population is maximum in that city, then it is very difficult for new to build a new establishment, and therefore either the population will decline or maybe it will increase but very slow. Okay, so in this particular you can say formula, the section BD is taken into account as a x bar. X bar can be calculated as dp by dt, which is using dp by dt, and which is like for section B D. Okay. There are other formula, geometrical increase formula, which is again a simple formula which you learn in mathematics earlier, like for interest calculation. Pn is equal to P0 into 1 plus R by 100 raised to n. Again, everything is clear. R is growth rate, N is geometric growth rate, and R can be calculated as the decadal growth rate of first decade, second, third decade, multiplication of this decadal growth rate raised to 1 by n. Okay, so R is decadal growth rate. Okay, um, here also it's a decadal. N is also the decadal growth rate. Number of decade. X bar is decadal growth rate, and n is the number of decades. Okay, so it's not yearly or annually. It's a 10-year growth rate. So that is why, like, the population survey or census survey is being done in every 10 year in one decade, right? So in 2001 we had a census survey. Now in 2011 again the census has been published. Now 2021 it is due. I think now it is going to be published in next few years, or maybe I don't know, but this time census is due, census survey is due. R can also be calculated using R is equal to Pn upon P raised to 1 by n minus 1, right? And here Pn is the population of any n decade, okay? And P is the population. I don't know how. Let's see how can we apply this. But these are the two formula. R, increase in population divided by original population. So it's a uh, growth rate that can be calculated in this way. Let's see the examples. So here, compute the population of your city or state for 2011 using 2001 census population. Compare the estimated population with actual census data of 2011. Forecast the population for 2021 and write your comment on forecasts. Use both arithmetic and geometric method. This is for you to solve the problem. You can take the population of your city and try to solve it by two methods. I will just explain the calculation of incremental increase method and decrease method. So this is another two methods where, so first two methods are easy, right? It's the simple application of the formula if you know the decadal growth rate. Now incremental increase method, Pn is equal to P0 plus n x bar plus n into n plus 1 upon 2 into y bar, where x bar is the average increase of population of known decades, y bar is the average of incremental increase of the population of the known decades. Incremental increase means if there is a certain increase in one decade and another amount of increase in um, the other decade, then the comparison of these two decades will tell you about the incremental increase in population. For example, here you can see in the table the population from 1930 to 1970 is given. The population was 25,000 in 1930 and it grown to 47,000 in 1970. In between, the increase in population in 1940 was 3,000, but in 1950 was 6,000, right? 34,000 minus 28,000, and so on. Now see, in 1970, the growth was less, okay? Between 60 to 70, the growth was less, and the population was increased by just 5,000. So when you calculate the incremental increase, that means the comparison of two increase will give you incremental increase. So in 1950, the increase was 6,000, In 1940, the increase was 3,000. So actually, in 1950, there is 3,000 like more increase in population compared to 1940. Similarly, in 1960, there is 2,000 more increase in population compared to 1950. Okay, and so on. But in 1970, there is a decrease, decrease in population by 3,000 compared to 1960. Right, 8,000 minus 5,000. So this is incremental increase, and so total of this will be 2,000, right, divided by 3, because average we want to know. So means there is an increase of on an average 667 person per decade. Incremental increase means if you are using the population of 1970, then you can say this is on an average increase in population. So let's so here homework, calculate the population in 1980, 1990 and 2000 using incremental increase method. So now you know everything of this formula. You know P0. If you are using 1970 population 40,000, 47,000, then P0 will be 47,000, and X bar, if 1980 means one decade after like 1970, X bar is average increase of population of known decade. So average increase can be taken as this 5,500 increase in population, or maybe it can be taken as a percentage. It's not necessary to take it as a percentage, right? Let me see. We have to take it as a percentage. X bar average arithmetic mean of population increase in the known decade, but it's not given it's a percentage or not. Okay, do you have your calculator? Can you calculate n into n plus 1? N is 1, 1 plus 1 upon 2 into y bar. Y bar is 667. So, do you have your lab calculators with you? Can anybody do? I will write the answer in this question. So you will just check the answer. Do you have any? Okay, anyone?
Yes, ma'am, I have it.
Okay, try to solve for 1980. I don't have book. I can not tell you the answer right now. This book is in my office. So let's say X bar average increase of population of known decade. P0 1970 47,000. Hmm.
Ma'am, is it 50,167?
Okay, let me also solve it. $53,167, right?
Yes, ma'am.
Okay. So it's a simple calculation. I will write the answer. This one I have to see let's see if it matches with book or not. Write your comments on suitability of all three methods. Okay, for this you have to go through the book. Okay, because you don't read much. I have already told you most of the theory. Go through the book and find out which method is suitable for what kind of, or with what kind of city, you can say. So suitability of the three method, you can write the comment on this topic. Okay. Decrease rate of growth method. Again, this is similar kind of calculation where percentage increase or percentage decrease is considered. So again the same way, the percentage increase in population in successive year is being calculated in third column. So first column year, second population, third column is percentage increase in population. You can again see the percentage increase was high in 1950, and then higher in 1960, and then it decreases in 1970 because of the saturation, maybe the saturation of the population. So now the decrease in percentage increase in population can be calculated by comparing the two percentage increase. So in 1940 there is a decrease, like lesser increase in population rate percentage compared to 1950, which is 9.4% less increase in population compared to 1950. In 1960 there is 2.1% less increase, or less, you can say less population, less rate of increase in population in 1950 compared to 1960. So you can see the 21.4% minus 23.5% is done, right? So we are comparing the successive years with the preceding year. Okay, then 1970 there is a means in 1960 there is a high increase in population percentage compared to 1970. So then overall average percentage increase or decrease using the sign also can be calculated, and therefore this can be used in this way. 47,000 plus 11.9. Now we know that there would be in next 1980, what will happen, there would be less increase in population, and that less would be by 0.03%, right? Right, is that clear? Because the preceding year will have higher rate of increase by 0.03. So the successive year will have less population compared to preceding year. So 11.9 minus 0.03 upon 100 into 47,000. So it's a 52,570. So what we calculated from earlier method, it was 53,167, and this is 52,570. And is that like significant, how much difference in two calculation? 597, right? If I compare it with 53,167, it's like just 1% difference in these two calculation, which is nothing, like it's a negligible. Okay, so this is like this two method gives you almost similar kind of answer. If you don't have like means if like the population is very huge, you do not want to calculate in any of the method, you want to just see the trend and extrapolate the trend, that is also being done, and uh, that is known as the graphical method. Comparative graphical methods, cities of similar condition can be compared, their characteristics, if their characteristics are same or similar, then we can project the population of new city for new city using the population growth rate of the similar city which is already in existence. So this is comparative graphical method. City of similar condition and characteristics are selected which have grown in similar fashion in the past, and their graph are plotted, and the mean graph is also plotted. The method gives quite satisfactory results. So if a new city is there which is growing, and you want to design any water demand or any water treatment plant for that city, you can take the population increase of similar cities and you can plot them, and you can take on an average one average graph, and you can use that graph for the other city which is similar to the two cities, two or three cities. So master planning method, big and metropolitan cities are generally controlled by development authorities in the planned manner. Now, only those expansions are allowed which are permitted or proposed in the master plan of the city, and the population are also fixed. So that is another way of controlling the not controlling, you can say, to to have a planned population growth in the city, the planned establishment in the cities. Okay. Ratio method, apportion method. I means there are too many methods. You can also go through this method, but in this method, the city census population record is expressed as a percentage of population of the whole country. In order to do so, the local population and the country's population for at least 4 or 5 decades is obtained from the census record. The ratio of local population to national population is worked out. A graph is then plotted between those ratios and the time and extended. Means now there is a plotting between the time, year, and the ratio of city population to national population, and it can be extended to the design period, and the population for the design period can be calculated. So it is again one of the method that can be used. Log logistic curve method. This is simple formula. It's a logarithmic. It assumes the logarithmic growth rate, and here like M can be. Let's see one by one. PS is the saturation population. P the population at any time T from the start point. P0 is the population at the start point of the curve, and M can be calculated as PS minus P0 upon P0, which would be a constant. And then because PS will be constant, first population, the beginning of the city, will also be the constant value. Say after saturation, it is almost constant. Either the city will not grow further, means in terms of population, or maybe the population will decrease little bit. PS can also be PS can be calculated using the formula given here, and N can be calculated also. The formula is given here. So this is how you can calculate all the three values and use them in the first formula and calculate the P for any given decade. Okay, so here one problem statement, where the problem is like the decadal population is given for the city, and the population for 2021, 31, and 41 needs to be calculated using all the methods. So it's a simple formula, right? In two period, this is another type of formula. In two problem, in two period of each 20 years, a city has grown from 30,000 to 1,70,000, and then 3 lakh. Okay, 20 years. So first 10 years, in two periods of each 20 years. Yes, so I think 10 years, right? 20 years. Okay, 220 years. Okay. So in first 20 years, the population grows from 30,000 to 1,70,000, and then in second 20 years, it goes up to 3 lakh. Okay. Determine the saturation population, the population of equation, the equation of logistic curve. Using the equation of logistic curve should be that, means P need to be calculated, the expected population after 60 years from the start. So here the solution is given. PS is calculated using the formula, M is calculated, N is calculated. The equation of logistic curve is P is equal to whatever all the values is written here, and then if T you are taking as 60 years, the expected population after 60 years, right? 60, then the population will be 3,23,000. So growth is not exponential now, right? The growth is slowed down, right? After 60 years, the population growth is only 23,470 compared to 60 years means again 20 years, right? This is 40 years between 30,000 to 3 lakhs, and then again 20 years means 60 years. So in the like last 20 years only the increase is 23,470. This is the homework for you. You can solve this problem. You can also use this log logistic method for calculation of population. As per the census record for the years 1911 to 1971, the population of a town is given below. Forecast the population for 1991. So this is the reference. You can use this book to solve more problems. Okay. So is there any question? Anything which is not clear?
I have a question in the minor solutions which were uploaded yesterday.
Yes.
The solution of the air balloon is it's given wrong, I think. Velocity square has been taken negative and all that. So the solution, I don't think it's correct.
Okay, I will see that. So it's related to balloon related problem, right?
Spherical balloon.
1 minute, 1 minute. I will note it down, otherwise I will forget it. Is there anything else? It's a minor one. Minor one. Question number. Can you tell me question number?
It is different for different students. Like
Yeah,
just the question order was shuffled.
Okay, okay. So it's a balloon.
spherical balloon question.
Air balloon question.
Okay.
Along with that, ma'am, even the calculations are wrong, and along with that, much of the data was also not given. We have assumed emissivity to be one, which is a very unreasonable assumption.
No, 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 no. Emissivity. You have given uh, your PPT, right? The value will be there. Or if you have assumed given
Emissivity is one for
if you have assumed,
emissivity is
and
one for black bodies.
there is a echo in my voice. You just close your mic so I will speak. Okay. So see, I don't know. The instruction were clear. I talked to my TA yesterday. One or two things I would like to explain you. If any value you think is missing in the problem, there might be the values given in presentation like ppts. Okay, you can use that value in case if there is no value. But let me explain. If there is no value in presentation, okay, you have not been taught any example of that kind of example, you don't have the value for that parameter, you can assume it. Okay. And assumption, anybody can make any assumption, but if you have solved the problem, you know the range of value and you make appropriate assumption. So for example, say for the value for density is not given. Okay, air density is not given. I know the air density value is approximately 1.2 to 1.3. Now, if I assume 300, 100, 10, 20, then it's inappropriate assumption. We cannot assume something which is weird. Okay, so if you you have solved the questions, you know like what would be the appropriate value for any of the parameter. You should.
Ma'am, but I don't think epsilon, if we vary epsilon even a little bit, the values would come within, the reasonable
Ma'am,
yeah, whatever reasonable limit it is that you are saying for emissivity.
Ma'am, plus the assumption of density is one thing, and assuming emissivity to be one is another thing. Ma'am, we cannot assume emissivity to be one. It's not a black body.
I'm telling you, you
It
have
should
to assume the
have been
appropriate
mentioned in the value.
number, right? If you are thinking, okay, so do you want to say that the value assumed one was wrong and it was given in the example, or
No,
what do you want to say?
ma'am,
You
even if it,
assumed it, or it was given in the problem?
no, it was
It was
not
not
given.
given, and if we had the value of emissivity should be given, or it should have been mentioned that we have to assume it as a black body.
Ma'am, other than that also, if we don't even talk about that, the calculations of velocity are totally wrong in the solution.
Balloon problem.
Yeah.
Okay, I will see that. I will see that. I have
Uh,
not checked
One more
answers.
thing, in the effective stack height problem, the pressure in the pressure it was written capital MB megabars, while we had to take it in millibars, so that caused a bit of confusion.
Mega bar? There is no mega bar.
Ma'am, a capital M denotes a mega unit.
No, a small m should be there. Millibar, maybe.
Ma'am, the
Ma'am, so
question
that
said
was
capital.
not written. The apart from that,
No,
the
it's a
paper
typo mistake.
AQI was not uploaded with the
No, no,
paper.
it should be typo mistake then. Okay.
Ma'am, but that causes confusion. So please, if that couldn't be taken into like account next time, and also the paper, if that can be uploaded at the time of the start of the exam, instead of 10 minutes later, when we are all in a
No, no,
frenzy.
that time we will try to maintain the time. Don't worry about that. I don't know why it happened. I just forgot this. So I will note down that delay in exam also. Why there was a delay in exam.
Okay, ma'am.
Down it. Okay. I will ask him. Okay. But
Okay,
the
please look
other thing
into
I
this
want to
spherical problem.
one other thing I want to say you, that in instruction it was given that you have to round off the value up to two decimal place after two digit after decimal place, right? Two digit after decimal place. However, many of you have written either three digit or maybe more. See, you are 250 students. We cannot check your paper one by one and then see like means your answer sheet and then see, oh, you have solved it very correctly. So I will. That is not possible. Generally, what we do, we if in instruction it is given that you have to round off to two digit, then you have to do that. Next time you will lose marks because of that. I'm telling you very straightforwardly that I will not consider this because it made a mess. There are many student among you who have not rounded off the answer, and they got like incorrect, and then now they are complaining, ma'am, I wrote 18.3511 and there was like 351. So it, I know there is no difference, it's an insignificant difference, but it is not possible for us to check each and every person the answer sheet, and then it's a manual checking for 250, or you are 300 student, in my class you are 300. So don't expect me to do this manual checking next time in major exam. Okay, if you have not followed the instruction, you will lose the marks. That's for clear. And I will not entertain any query related to this kind of mistakes. Okay, so I will take care of that minor one, balloon related question and delay in exam. Is there anything else? And the constants should be given. Okay, we will give the constant values of each constant in next exam. Okay, now tell me, is there anything else? No. Can we end the meeting? I will download the attendance list. Okay, I am leaving. Okay. Stop recording.